In this video, we're going to make a quick little script that we can just drag and drop onto any prefab that allows it to make the object wrap around the screen when it hits the edge. So in this case here, you can see that my lasers will wrap through the screen, these asteroids will as well, and the player does. Now, one thing to also note, the way I set this up is if you adjust the screen on the free aspect size at runtime, it's still going to update correctly as well. So it will take account in any screen size changes. So let's get started here. So in this project right now, I just have a simple little asteroid style game. When I run it, I can control the player, move them around, but if we go off the screen, we keep going up and all the meteors will keep going. Now, since I want multiple different types of objects to wrap around the screen, it doesn't make sense to put the code on each script and repeat that code over and over again. So I'm just going to make it a separate script that we can just drop onto any prefab we want. And now the prefabs I want to use are a player, a laser, and an asteroid. So all three of these have a rigid body. So I'm going to make the script rely on the rigid body component. So let's just create a new script here. I'm just going to call it screen wrap. I'm going to open up this script. And the first thing I'm going to do is, since this is going to rely on the rigid body, well, a rigid body 2D, I'm going to make it require that component. So I'm going to put the attribute require component, type of, and we want rigid body 2D. So now all this is going to do is, if we add this script onto an object that doesn't have a rigid body 2D, it's going to automatically add one, because otherwise we're going to get an error. Okay, and next thing I'm going to want to do is I need to get a reference to that rigid body. So I'm just going to make a private variable rigid body 2D. I'm just going to call it my rigid body. You can call it whatever you like. Okay, and in start, I'm just going to do my rigid body equals get component rigid body 2D. Okay, so we now have a reference to that rigid body. Everything else we want to do is going to be an update. Now, there are some better ways you could make this a bit more optimized for this video. I'm just going to make it very simple and basic. And it's going to do checks in update that you could kind of cache them so you don't have to do it all the time. And what I mean by that is, just in case the screen size of the game changes during gameplay, I'm going to do a check for the camera positions every frame. So what that means, every object that the script is on is going to do that check. So if you want to do something like this and make it more optimized, later you would probably want to do something where you only do that once for all of the objects, because the screen size is going to be the same. But I don't want this video to be too advanced or confusing for beginners, so I'm just going to leave it as is for right now. So just know there are better ways that you can optimize this later, but it's going to work fine. Okay, so the first thing we need to do here is we need to use a vector3. I'm going to call it screen position. And we need to find out where this object is on the screen. So what we can do is access the camera.main. And this is just a shortcut we can access our main camera with. And then we want to use world to screen point. So what this is going to do is take the position in world space, and it's going to convert it to the screen space. So almost like the canvas or the UI. And we need to pass in our current position. Now I can quickly bring up the Unity documentation on this. So the quick summary that it's giving us here is it's going to transform position from the world space into screen space. And now screen space is defined in pixels. So the bottom left of your screen is 0, 0, and the top right is the highest amount of pixels on the width and the highest on the height. So think, if you have something like high definition, which is 1920 by 1080, that means the bottom left corner of your screen is pixels 0, 0, so 0 on the X, 0 on the Y, and then the top corner would be 1920, 1080. So something right in the middle of the screen would be half and half. Okay, so now this variable, we know where our position is on the screen, but we don't know how big the screen is yet. So I'm going to make a couple of variables here, and I'm just going to name them, so hopefully it makes sense to you what they are. I'm going to call this right side of screen in world. So this will be the edge of the screen on the right, but in world units, not pixels. So again, we can use camera.main, screen to world. And now we got to pass in a position. So instead of our current position, I'm going to put in a new vector 2. And what I want is the screen.width and the screen.height. So this is putting in basically the top right corner of the screen in pixels. So it's more or less doing the opposite of what we did here. So let me just finish this line and then I'll try to explain it a bit more for you. So we're getting the red line because we only need the X, because this is going to return 2 values. So to explain this a bit better, this first line here, I'm going to put a comment. Get the screen position of object in pixels. So depending on the size of the screen, it could vary. On one screen, it's going to be a different number than another based on what resolution they're playing the game at. So this is going to actually tell us where it is. Now this next variable, now this one, the variable name kind of already describes it, but I'll make the little comment. So this is going to pass in the pixel value. So if you use screen.width and screen.height, they're going to return how many pixels wide and how many pixels high the screen is. So depending on the resolution that the user is playing at, they're going to vary. So if we're playing at HD, which is 1920 by 1080, the width is going to be 1920, the height's going to be 1080. So what this does is we use the camera and this method screen to world point to take that position in pixels, which is the very top right of the screen, and convert it into world, which is where our objects are. And then we only want the X of it here. Now I'm going to do the same thing for the left side. So for this one, we want the camera.main, screen to world point again. But for our position, we just want to pass in 0 and 0, which is the bottom left of the screen. And now I want to return the X of that. So now we get both of them. Now you could do this all in one line and store it in a vector2 variable. But for this video, I wanted to break it down into each separate variable so it's hopefully easier to understand and see what's going on here. So now this gives us the right and left side X value of our screen. And then we want to do the same thing with the Y. So I'm going to do float. I'm going to do top of screen in world. Same thing. We'll do camera.main, screen to world. Now in this one, we want to pass in a vector2. We're going to do screen.width, screen.height, and we just want to return the Y. So as you can see, this way is very redundant. We're typing out a lot. So you could save this hassle and you could compress this code, but it gets a bit harder to read if you've never done it before. So after you follow this guide, if that makes sense to you, go ahead and try to clean that up. Okay, and then we just need the bottom of the screen. So I'll do, oh, that should be lowercase. I'll do bottom of screen in world. So we're going to put the camera.main, screen to world, vector2, and we're going to pass in 0 and 0, and just take the Y. Okay, so now we have all the variables we need. So right here we have our position in world space. Now we have our position in the screen space in pixels. Then here we have the right side of the screen in world space. We already know it in pixels because that's built in with screen.width. Then we have the left side in world. and then the top and bottom in world. So those are basically the bounds of our screen, but now we actually have to do the checks. First thing we gotta do is I'm gonna check if player is moving through left side of the screen. Okay, so we need to make some if statements here. So first thing we gotta see, are we going through the left? So we'll do if screen.position.x is less or equal to 0. So we also have to do another check, because when we do hit, say if we move into the right side and we teleport over to the left for our wrap, we could trigger this condition there too. So we want to also check to make sure that the object is moving to the left, because if it's moving to the right, that means it already wrapped and it came from the other side, or it came in from off screen. Because in this case, I'm spawning the asteroids off screen. I don't want them to spawn on the screen so you see them. I spawn them off screen and then they move in. So we don't want to trigger them with any of these statements when they're first moving in. So let's add another condition here. Let's do and if my RigidBody.velocity.x is less than 0. So anything less than 0 on the x means you're currently moving to the left direction. So this is going to say if your position is 0 or less and you're moving to the left, do this code. Okay, and in that case, what we want to do is we want to set the transform.position equal to a new vector 2. We want to put in the right side of the screen in world units. And we want to leave our position on y as the same. Okay, so before we write a whole mound of code, I want to test this and make sure this works. We don't want to add all the conditions and then find out our math or our logic is completely wrong. So let's go back into our game here. And for the current time, I'm only going to add it to the player. I'm not going to test on everything. Again, we want to keep it as simple as we can for testing to make sure it works. So let's add screen wrap to the player. We have the script down here. Let's run the game. Okay, I'm going to move over to the left. Okay, and I wrapped over to the right. But if I go any other direction, nothing's going to happen. We only have the one logic in. But at least we know that one is working. So now it's time to move on to the next. So the next one I'm going to do is if the player is moving through the right side of the screen. So now I'm going to do else if, since I already have the first if. I want to check if the screen position.x is greater or equal to the width of the screen. So this is in pixels, so we're checking the pixel width. And again, we need to check our velocity, so we want to make sure we're moving in that direction. So we want to check velocity.x is greater than 0. So this one is basically the same thing except on the x. Or, sorry, basically the same thing, but on the right side. So we want to make sure we're moving to the right. Okay, and if that is the case, we want to set our position to be a new vector 2. We want left side of the screen. And then transform.position.y, so we don't change the y. Okay, now I'm just going to test this again quick. So now we should be able to move back and forth between the left and right side. Okay, so I already did test the left, but I want to make sure again that I didn't make a new bug. Okay, so I can move to the left. If I move to the right, I loop back over. Okay, so perfect. Those two are working. On to the next one. I'm going to do if the player is moving through the top of the screen. So we're going to do an else if. Screen position.y this time is greater or equal to, we want to put in the screen.height. Okay, and then again, we got to check our velocity. So we want to check if our velocity.y is greater than 0, meaning we're moving up. Okay, if that's the case, we want to set our position to be the bottom of the screen. Oops. New vector 2. We're going to go with transform.position.x because we don't want to change our x on this one. And we want to put bottom of the screen. Okay, so for this time, I think both are going to work fine. So I'm going to do both of these testing at the same time. So let's just finish this. If player is moving through bottom of the screen. Do an else if. Screen position.y. We want to check if it's smaller or equal to 0. Okay, and then we want to make sure we're moving down. Set our position equal to new vector 2. We want transform.position.x and then top of screen. Okay, so we should have all 4 directions now. So let's go and test this with our player. Okay, so that's working. Let's go through the top. Top is working. We'll go back down here. And then even if we go through near a corner, it should work fine. There, so it's all working. Okay, so we have that. And then just to show quick why I did add those extra checks in there. I mean, for the most part, for most games, it's not going to matter. But say if you were playing and we had this as, say, free aspect. So I can make some really weird size of my screen here. And see, it's working fine. We're looping through. If we didn't do those checks every frame, it would only check at the beginning of the game. So if anything did change, say if you had your game where it was running in windowed mode and the user could change the size, those hard numbers at the beginning of the game wouldn't be the same. So that's really up to you if you need that or not. It does add a lot of extra checks in the update call, but they're going to be very minimal, and there are ways you can clean that up if that's something you want to do. So let's test this. I added it onto our player prefab, but let's go to our prefabs folder. So we have an asteroid. So we should be able to just add the screen wrap script right onto the asteroid prefab, as well as the laser prefab. And it should just work on any of these objects now. So instead of having to do code on different game objects and different scripts. Okay, so we saw my laser went through. I just hit an asteroid there, and let's see if these go through. Okay, so this guy's going to go up. He should come through somewhere around here. He did. Right now they all have collisions, so they're bumping into each other, but we see they're going through and working. Okay, so that's it for this video. That's everything there. One thing you may want to look into adding is you could add some logic into your screen wrap where it takes an extra image of whatever object is wrapping. Because right now, if we look, basically once the object hits the corner, it's going to pop in on the other side. But if you used another image, you could display one coming in on this side while this one is still moving off. And that'd be very easy to do too. If that's something you want to see me make a video on, just leave a comment below and I'll make that as well.